Oh, so sorry. So today we're talking about one-step inequalities. I didn't realize I was recording. So you solve inequalities pretty much the same way that you solve equations. There's one little difference, and that's when you multiply or divide both sides by a negative. But other than that, it's pretty much the same. So for example, on number 1, to get the a by itself, we would do the opposite. So the opposite of divide by 15 is multiply. So on this problem, to get the a by itself, we're going to multiply each side by 15. Then we have a is greater than 150. So that's our important number. There's no line underneath it, so it's going to be an open dot. I want all of the numbers bigger than 150, so 150 is my smaller. So bigger than 150 would be this direction, so I shade it. Okay, and then again, for example, like on number, how about number 8? So on number 8, we're trying to get this n by itself, so we have to do the opposite. So the opposite of minus 15 is add 15. What we do to one side of the equation, we must do to the other side of the equation. So now we have n is greater than or equal to 0, because 15 plus negative 15 is 0. So my important number is at 0. I need to put a bubble there. Notice that there's a line underneath it, so that means that it needs to be filled in. I want all of the numbers bigger than n. The alligator is eating the n. So I want to shade to the right. Okay, let's look at number 11. Oh, sorry. Technical. Okay. There we go. Oh, maybe we can zoom in. Oops. Whoa. Just hold on.
Human difficulties.
Okay, so now we are trying to get the n by itself. I'm going to rewrite this so that you can see it a little bit better, or rather you can see my work a little bit better. So we try to get the n by itself, so we need to do the opposite of what's happening. When a number and a letter are right next to each other, it means that they're getting multiplied. So the opposite would be divide. So I'm going to divide each side by a negative 8. So this is a special case. When you multiply or divide each side by a negative, I don't care about any other numbers. I only care about what's happening on each side. So notice that there's a negative 8 on the right side and a negative 8 on the left side, and I'm dividing them. So add, subtract doesn't matter. It's only multiply, divide. I'm dividing by negatives on each side of the equation, or my inequality. So that means this symbol needs to flip. I still have my n on my right, and 24 divided by negative 8 is negative 3. This becomes my new answer. If you do not flip your symbol when you multiply or divide each side by a negative, your answer will be going the wrong way. So you need to be very careful about that. It's a common mistake. Then my important number is at negative 3, so I'm going to put my bubble there, and I'm going to fill it in because there is a line underneath it. Now, my alligator is eating my negative 3, so this is the greatest piece, is negative 3. So all my numbers smaller is everything else that I would like to shade. That would be these guys. So again, be very careful when you multiply or divide by a negative on each side. You need to make sure that you're flipping that symbol. I'm going to look for one more example. Oh, just kidding. I'm going to write an example for you so that you can see another one. So if I had x divided by negative 2 is greater than 5. Okay, so on this one, we're trying to get this x by itself. So in order to do that, we have to do the opposite of what's happening to it. What's happening to my x is it's getting divided by negative 2. So the opposite is multiply. We do to one side, we do to the other. So now I'm multiplying on each side by a negative number. When that happens, this symbol needs to flip to the other side. My 2's cancel because negative 2 divided by negative 2 is 1, so I'm left with x on the left-hand side. And on the right-hand side, 5 times negative 2 is negative 10. If I wanted to graph it, which of course I do, I'm going to draw a cute little graph and then negative 10 here. Since I don't have a line, it's going to be an open dot. I'm talking about 10 being the biggest because it says all my other numbers are smaller than or less than negative 10. So I want to shade to the left for this one. Okay, let's just compare that with another problem right next to it. Let's do negative 4x is less than or equal to negative 16. Okay, so here, actually, let's make this a positive 4x. I'm sorry. Okay, So here we have a 4x is less than negative 16, and I'm trying to get this x by itself. So again, I have to do the opposite to undo. So I'm going to divide each side by 4. My 4's cancel on the left, leaving just my x. Over here, I need to divide. So I have negative 16 divided by 4, which gives me a negative 4. Now my answer is negative, and that's fine. But notice that the numbers that I divided on each side are both positive. So my symbol stays the same way. Only here on the left side, where I've done this example, I've multiplied each side by a negative, so now my symbol flips. So I don't care about any of the other numbers, I only care about what I'm doing to each side. Then again, we need to graph this. I have a closed dot at negative 4, and the reason that it's closed is because of this little line here. And I'm talking about all the numbers that are smaller than or equal to negative 4, because my alligator is eating my negative 4, which makes my negative 4 the biggest. So that means I'm going to be shading to the left, and that is my completed inequality.